Good morning. The next article, actually it is last but one article of this chapter. Unit step function. Unit step function is used to find out the transforms and inverse transforms of various functions. It is important because it is used to find transforms and inverse transforms of some functions which may not be found by using the earlier methods. Before this, we have used many methods for Fourier transforms and Laplace transforms. We also worked out their inverse transforms. So this is somewhat better method. Why it is better method? Because using this method, we can find transforms of those functions which was not possible with the help of the earlier methods. Why this method is known as unit step function method? This is because this method is represented this way. This axis is taken as u of t minus a axis. Actually, it is function axis. I am writing this as u of t minus a. It is function axis. Let me consider this as t axis. This, let us suppose, value of this function is 1 here. Unit. Up to certain value of t, value of this function is 0. And at this certain value, the function becomes unity 1. If it is corresponding to a, we can write this function as u of t minus a. And how to represent this mathematically? U of t minus a may be represented mathematically as a function which is 0 for t less than a and 1 for t greater than equal to a. U of t minus a is a function which is 0 for t less than a. So whenever this t is smaller than a, we find value of the function is 0. U of t minus a is equal to 0 for t less than. As soon as value of a becomes equal to or greater than a, suddenly the function rises and becomes 1 or unit t. Therefore, this function is known as unit step function. Let us see how to use this unit step function for finding transform of some functions which could not be possible with the help of the earlier methods. Let us go to the first example. First example is, my script it is here. The first one. The function given is this. F of t is equal to 8 for t less than 2, 6 for t greater than equal to 2. Let us see how to get transform of this. Solution: f of t is equal to, let me write the same function as 8 plus 0, 8 minus 2 for t less than 2, for t greater than equal to 2. This is for the 8 is taken common and what left? 0 left here, minus 2 left here, for t less than 2, for t greater than equal to 2. This is equal to 8, minus 2 is taken common, what left? 0 here, 1 here. This is for t less than 2, this is for t greater than equal to 2. And that is nothing but f of t is equal to 8 minus 2 u of t minus 2. Now it is step function as per our definition. It is unique step function and therefore it can be now written as f of t is equal to 8 minus 2 u of t minus 2. Let us get its Laplace transform. This is equal to it is constant taken outside the integration. Integration of e to the power minus st is e to the power minus st by minus s. Limits 0 to infinity minus 2. Integration of this e to the power minus st by minus s 2 to infinity. 8 is now not part of this unit function. Okay, so limit taken for these are 0 to infinity. Whereas this is corresponding to u of t minus 2. Limit starts from 2 and therefore 2 to infinity limit is taken. Now let us put these limits. 8 into e to the power minus infinity minus e to the power 0 divided by minus s minus 2 into e to the power minus infinity minus e to the power, for this t we have to put 2, so it will be minus 2s divided by minus s. This is for the 8 into, this is 0 minus 1 minus 1 divided by minus s, 1 by s. 1 divided by s. Minus 2 into, it is 0. E to the power minus infinity is 0. Minus e to the power minus 2s divided by minus s. So it will be simply e to the power minus 2s divided by s. Denominator is same, so this can be written as a single term, and that is what? 8 minus 2 e to the power minus 2s whole divided by s. This is Laplace transform of the given function f of t. And what is f of t? This. This is about the first problem on unit step function. Now let us go to the second one. Before that, let me clean the code. It is so simple. I hope you understood it. The second one now, and it is f of t is equal to and the problem is f of t is equal to e for a less than t less than b and 0 for t greater than b. Let us see how to solve this. The solution f of t is equal to, let me take this t common. So 1 left here, 0 left here. It is corresponding to this condition. It is corresponding to this condition. This is nothing but e into u of t minus a minus u into minus u of t minus b. This function is one unit step function when t is between a and b, and therefore u of t minus a minus u of t minus b will be the unit function. This is further Laplace transform of f of t is equal to e into Laplace transform of u of t minus a minus e into Laplace transform of u of t minus a. This is nothing but e into integration from a to infinity e to the power minus st. 1 is here. 1 into e to the power minus st is e to the power minus st dt minus e into integration. Now limit b to infinity. 1 is here. 1 into e to the power minus st e to the power minus st dt. This is equal to e into e to the power minus st by minus s limits a to infinity minus e into e to the power minus st by minus s limits b to infinity. Let us put the limits e into e to the power minus infinity minus e to the power minus sta divided by minus s minus e into in the bracket e to the power minus infinity minus e to the power minus st whole divided by minus s. This is equal to, this is 0, minus minus will become plus, so it is e into e to the power minus as divided by s minus e to the power minus infinity is 0, it is minus 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 plus e times e to the power minus ds divided by s. Denominator is same and therefore Laplace transform of f of t is equal to e into e to the power minus as minus e to the power minus ds whole divided by s. This is the Laplace transform of this function. Okay, so this is about the second example. Hope you understood. Let us go to third one. And third problem is f of t is equal to t minus 1 for 1 less than t less than 2, 3 minus t for 2 less than t less than 3. F of t is equal to t minus 1 for the condition 1 less than t less than 2 and 3 minus t for the condition 2 less than t less than 3. And let us see how to solve this. And that is f of t is equal to t minus 1 into e of t minus 1 minus u of t minus 2 plus 3 minus t into u of t minus 2 minus u of t minus 3. This is for this one, this is for this one. This into this t minus 1 into u of t minus 1. It is corresponding to unity with lower limit 1. U of t minus 2 is here, u of t minus 2 is here. From these two we can take minus u of t minus 2 common. What left? T minus 1. It is plus, minus is taken common here, so 1 minus will appear here for this term only, not for this, and this will become minus 3 plus 2. And what left? Plus, minus is here, this into this. Let us take this minus here, so it will become t minus 3 into e of t minus 3. T plus t, 2t, minus 1 minus 3 minus 4, 2 can be taken common. What left here? T minus 2. So this will be t minus 1 u of t minus 1 minus 2 into t minus 2 into u of t minus 2 plus t minus 3 u of t minus 3. And Laplace transform. This is now what? The function f of t. This function is this function. T minus 1 into e of t minus 1 minus 2 into t minus 2 u of t minus 2 plus t minus 3 u of t minus 3. Now, Laplace transform of this function. Do you think that we could have solved this? We could have obtained transform this using earlier methods? No, not possible. Now, this can be further. Laplace transform of this. This is for integration of 1 to infinity t minus 1 e to the power minus st dt minus 2 into integration the limits 2 to infinity t minus 2 into e to the power minus st plus integration of 3 to infinity t minus 3 e to the power minus st dt. Function of time, integration by parts. Function of time, integration by parts. Function of time, integration by parts. And that is f of x into integration of g of x. Limits for these two 1 to infinity minus integration of 1 to infinity f dash of x 1 integration of differentiation of minus 1 0 differentiation of t with respect to t 1 into e to the power minus st dt divided by minus s minus 2 into f of x t minus 2 into integration of g of x e to the power minus s t minus s limits 2 to infinity minus integration over 2 to infinity f dash of x 1 no need to write 1 integration of g dash of g of x e to the power minus st divided by minus s dt plus bracket is taken here also. Let us take a bracket f of x t minus 3 into e to the power minus st divided by minus s limits are 3 to infinity minus integration of 3 to infinity f dash of x is 1 and integration of e to the power minus st is e to the power minus st minus s dt. Find value of this infinity minus 1 into e to the power minus infinity 0 minus t minus 1 0 0 into e to the power minus s 0. So this term will become 0. Similarly, this term will become 0, not this. This is left. This term will become 0. Infinity minus 2 into e to the power minus infinity 0 minus t minus 2 2 minus 2 0 0 into e to the power minus 2 is 0. This will become 0. With the same reasoning, this term will also become 0. Now only 3 terms are left. This term minus 2 times this term plus this term. Let us collect this term because it has become 0, minus 2 times this term because it has become 0, and plus this term plus minus minus this has become 0, and this is 4. This is equal to minus minus plus, and so it is e to the power minus st. Let me put this minus as it is divided by s squared. Integration of this is e to the power minus s divided by minus s. Minus s into minus s, s square plus s square minus this minus will be left as it is plus s square. Minus 2 will be as it is. This minus will become this plus. This minus will become plus. And it is e to the power minus st by minus s. Limits are to be substituted here 1 to infinity plus 2 times e to the power minus st divided by s square 2 to infinity. This minus has become plus. Then plus e to the power minus st minus will be there, minus s and minus st become pluses. 3 to infinity. This is equal to minus e to the power minus infinity minus e to the power minus 2s divided by s square plus 2 into e to the power minus infinity minus e to the power here 1 is there, so only 1 is minus 2s divided by s square minus e to the power minus infinity minus e to the power minus 3s divided by s square. This is 0 minus minus plus e to the power minus s divided by s square. 0 minus plus minus minus 2 into e to the power minus 2s divided by s square. Minus minus plus because e to the power minus infinity 0 e to the power minus 3s divided by s square. This is nothing but s square is there in the denominator of all the three terms, and so let me put this as L of, that is Laplace transform of f of t is equal to e to the power minus s minus 2 e to the power minus 2s plus e to the power minus 3s whole divided by s square. This is the Laplace transform of given function using the unit step function. One more problem is there. Tomorrow we shall go for one more problem and the last article of this chapter. Solution of simple differential equation using Laplace transform technique. We shall do it tomorrow. Thank you.